to 3. When you differentiate a constant, what would y dash become?
0.
0, so that one's done. Nikki, y dash for x, what would that be equal to?
1x.
1, no, not 1x.
1, yeah.
You have to reduce it by 1, so just 1. Y dash equals to, Larson, for x plus 3.
Just
X
1.
just becomes 1, plus 3 is gone.
Yeah.
Y dash, Natalia, 3x.
Just 3.
Just 3, too easy. This one here, you first expand, so 2x plus 6, and then y dash equals, well, just becomes 2. This one, a lot of students have problems with it because they're thinking, oh, x on 2, I don't know what to do there, I don't get it. But don't forget, x on 2 is the same as just half of x. So really, the answer is just going to be half. Right? It's pretty much with x is whatever's in front of it. That's how you think of it. It's just an x. It's what's in front of the x. Y dash for negative x should become negative 1. Y dash for negative 5x obviously becomes negative 5. Cool. Let's cover the rest. All right. Let's go again, I guess. Effie, y equals x squared.
2x.
Y dash equals 2x. Bring the 2 down, subtract by 1. Nice and easy. Next one, y dash equals, Larson.
2x minus 4.
2x minus 4. Y dash equals, Nikki.
9x minus 2.
Ooh, no, not right. You want to try it one more time?
9 minus 2.
Oh, very close.
2x.
This squared must decrease by 1 power. So it's going to become an x. Do you get that? Do you fully get that? So if it was cubics, what must the cubic drop down to?
2.
Yeah, you must remember that.
Yep.
Okay. Next one, Natalia, y dash.
12x squared minus 6x minus 2.
Done. And that is it.
Sam,
Yes?
are you sharing your screen?
Yep. Yeah.
I can't see it.
Hold on. Stop sharing. Start sharing. Can you see it now, Aiden?
Yeah.
Okay. Y dash. All right. Aiden, do you remember what this one was called? To be able to differentiate this?
What was it? The chain rule?
Yeah, it started with C, chain rule. Do you want to try it? So you bring the 2 down.
Yeah.
And then? Yeah, write it down.
Be
Do you know it?
Yeah. It'll be
Go.
8.
8
Then is it x minus 5
to the power of?
of nothing?
Yeah,
One.
well, technically of 1. But yeah, good job. Done. So you brought the 2 down. You keep that the same, and then you take away 1 from the power. Beautiful work. This one, why is it a product rule? Because you've got 2 x's that are multiplied. Right? You've got an x multiplied by an x, whereas here, this question here, you have a number multiplied by x's. That's not product rule. Product rule, we have to do u dash v plus v dash u. Y dash. Or I might start writing the other version because it's important for you guys to also learn dy dx. dy on dx also means y dash. So let's start writing it so we can get used to that. All right, u dash. Yeah, Larson, let's try this one. U dash. What's u dash?
X. Oh,
Well, dash, u dash. So you're going to differentiate that. You're going to
just
differentiate
X.
it.
Oh,
No.
1.
1. V plus V dash.
Plus 2. Yeah, 2. X plus 5. Minus 5. Times X. 1. Yeah.
No, you were right.
Yeah.
Time V dash times U. U is X. Unless you were saying 1 because of the derivative of the inside.
Yeah.
And then it's good to know that you can see an x minus 5 that's common in both. So you should learn to factorize that. And then you're left with x minus 5 plus 2x. 2x plus x is just 3x minus 5. Okay, this one here, again, it's not product rule. There's just 1x. So the answer for this one, you just bring the 3 down, take away 1 from the power, times by the derivative of the inside, but there's nothing to differentiate, so it's just times by 1, so we're ignoring that so far. Product rule, 2 x's, so y dash becomes u dash v, derivative of x is just gone, so x minus 5 cubed plus v dash times u. Again, what's common in both of them? Obviously, x minus 5 squared is common. What's missing from here and here? You're missing an x minus 5 plus a 3x. 3x plus x is 4x, and you're done. Equals x minus 5 squared, 4x minus 5. This one here, y equals 6. 4 times 6x take away 5 all squared, so therefore dy on dx, 4 times 2 is 8, 8 times 6x take away 5, take 1 away from the power, times derivative of the inside, you still have to differentiate the inside, right? So that's just 6, 8 times 6, 48, 48 times 6x take away 5. Okay, any questions?
Can you do the last one again?
Yep. So, if I've got what you're meant to do, you bring the 3 down. Bring the 3 down, which becomes 18. This becomes 8x, take away 2, to the power of 2, but you have to, with chain rule, it says you have to multiply it by the derivative of the inside. That means you've got to differentiate the inside. So what's
So
the
it's
derivative? So it's 8, yeah. And then 18 times 8 is 80, 144. So your answer becomes 144, 8x take away 2 squared.
What about 17? What did you get? Question 17.
Yeah, it's the same thing. 4 times 2, 8. 6x take away 5, power of 1 times.
Where does 6 come from?
Differentiate the inside.
Oh, yeah, never mind.
Yeah. Exactly the same.
Yeah.
All right. So go ahead, you guys. Now try these on your own, just quickly. Product rule, normal, product rule. Let's try 18, 19, 20. Right back.
Sam. Sam.
All right, who wants to try the first one? See if they put it right. Come on. Let's give it a shot, even if it's wrong. Go.
6x minus 5 squared.
Yep, so u dash v, you can't do anything with the x, so 6x minus 5 squared, plus
Plus 2.
v dash, yep, 2
6x minus 5.
to the power of
1.
1 times
6 times x.
times 6, because you've got to differentiate the inside, then you still got the v dash u, you still got the x. Perfect. That's full mark. And then factorize.
6x minus 5. I did it again, but I times 6 and 2.
Yep, 2 times 6 is 12x, like that.
I don't get what you do with the square brackets, that part.
The square, okay, so you're factorizing here. What's common in these two?
6x minus 5.
I took that out, and what's remaining? This was squared, so
Yeah.
obviously that's the power of 1, there it is. And then what's missing from this bit here? You got missing a 2, the 6, and the x, which is 12x. This looks confusing, but if you want me to show you in a different way, all you're doing is something like this. If I gave you x squared plus 2x y z, right? Take out x. What are you left with?
Squared plus 2.
X plus 2 y z. That's how you factorize. When you take it
Oh,
out,
yeah.
yeah, same thing. That's exactly that. Instead of x, it's 6x take away 5. So when you take out one of them, from here, squared, you're left with another one still. Plus, that's already there. And you expand this, so you're left with 2 and 6x.
Yeah.
You can't, if you still can't see it, then the only thing I can say is you've got to now expand it. Can you see 6x take away 5 times 6x take away 5? That gets you 6x take away 5 squared. 6x take away 5 times 12x is 12x times 6x take away 5. So if you expand it, you will get the top.
Yeah.
And then obviously 6 plus 12 is...
So if I didn't do it, can I still get full marks?
You will not get full marks for the first line.
Okay.
Okay, 19. Who wants to try 19?
Sam,
Yeah.
I didn't quite understand the 18, like the question.
Which bit?
The second line.
Do you know
The first line, you know how you did like 2 bracket 6x minus 5?
Yeah.
How'd you get that?
So u dash v plus v dash. How do I differentiate 6x take away 5 squared? So what is v dash? Tell me. What's the derivative of this? No, you don't know?
Mm-mm.
Okay, so you bring the 2 down.
Okay.
6x take away 5. Power of 1 times differentiate the inside. 6. That's
Okay.
rings a bell. Bring
Yeah,
the 2
yeah.
down and then times, and then v dash times u.
Yep.
That's the one, and u is x. And then this line here, we've just factorized 6x take away 5 out.
Okay.
And then 6x take away 5, what's missing? You're still missing the 6x take away 5 from this first bit. Plus, you're missing 2, 6, and an x, which is 12x.
Okay.
Simplify it. We're going to do it again in question 20. Try 19. 19 is just a product rule. I mean, chain rule.
Okay.
Okay, do you want to give me the answer for question 19, Neda?
I'm still doing it.
Okay. Do you want to do it together? Yeah.
Oh, okay.
Yeah, tell me what you would do. What's your first one?
Do we have to write the formula or something?
Bring the power down.
Yeah. So
Which is
3 times 4.
12. Yep.
And then you're
And then rewrite
6x minus 5.
to the power of
3.
2.
2, sorry.
2 times differentiate the inside. You got to differentiate
6.
these two again, which is just 6. So the answer is 72. 6x take away 5 squared.
Yeah.
Question 20. U V. So the formula, I'll write it up again. U dash V and V dash U. U dash. What's the derivative of U? Nikki, you want to try this one?
20x
20x to the power of?
4.
Yes. And then V.
6x minus 5.
Cubed. Okay. Plus?
Plus
Yeah, V dash now.
3 6x minus 5 times,
Yeah, you keep forgetting to say that. Powers. What about your powers?
oh sorry, 2
2 times.
4x 5.
You're close. V dash, you haven't finished. So you got to differentiate the inside.
Oh, 6.
And then U.
And then times 4x 5. Yeah.
Next line, I guess we'll do a bit slower. Three times 4 is 12. 12 times 6 is 72. X to the power 5. 6x minus 5 squared. Okay, what do you factorize out, Nikki? From
6x
20
minus 5.
Well, hold on. From 20 and 72, firstly. What's common?
X to the power of 4.
Yes, that's correct. And what about the numbers 20 and 72?
Oh yeah, you can factorize that.
I think you can at least factorize 2. Can you factorize 4? I believe so. You should be able to factorize 4 out. Yeah, 4 would be the highest number you can factorize out from 20 and 72. So 4, x to the power 4, and 6x minus 5 to the power of what?
2.
2. Good job. Now, pretty much what's missing from 4 and 20? Go. 4 to get into a 20. What are you going to have here?
Oh, like 5.
Yeah, you'll have 5. Then x4 is already x4, so that's perfect. You've got 6x take away 5 squared, but you need it to be cubed. So 5 times.
6x minus 5.
Beautiful. That's good factorizing there. Plus 472 is 18.
18, yep.
18, and then x, because that's 5, that's 4.
X, yep.
And I think that's it. That's squared, and that's squared already. You're done. So, good factorizing there. Thank you. 6x take away 5 squared. 30 plus 18 is 48. Minus 25. And that's it. You're done. That was a hard one. A little longer one. Alright, I want to jump into some of these quotient rule questions. Maybe we'll do these last few. Okay. Question 28. Who's comfortable to start this one?
Me.
Yeah, go ahead.
Well, not confident, but I think I
Yeah.
can do it.
Yeah, go. That's fine.
Okay, so the formula it's y
Ooh,
dash
hold
equals
on, hold on. Are you thinking quotient rule?
yeah. Oh, isn't it u dash v minus v dash u over v squared?
Yeah, but it's not for this one.
It
Now,
isn't.
no, this one's a quotient rule.
Mm-hmm.
This one's a quotient rule, and this one's a quotient rule. Now, tell me what is the difference between these three and this one on the top?
Or the numerator doesn't have like x.
X. Perfect. So if there aren't two x's that are divided, like this one here, it's
Mhm.
not quotient rule. These ones are quotient rule. Really important to get that. Maybe make a note of that. So
Okay.
same as product rule. This is a product rule. This is not a product rule.
Mm-hmm.
Product, not product rule. So the difference is the fact that two x's are multiplied compared to just the x by itself. There. So this is not a product rule. This is just like you can't have x's in the denominator. So what would you do? Like this to the power of what?
-2.
Perfect. So at first you can't actually even differentiate. You have to change your power of 2 to -2. Once you've got that, then you'll use just your basic chain rule. So
Mm-hmm.
d1 dx equals, go ahead.
-8.
Yep.
Bracket 3x minus 4. Would it be -3 or
Correct.
Yeah.
Times
3?
24. -3 again goes back down in the denominator as +3. Perfect. Anybody have any questions about that one? Okay. Let's go again. Question 29. Who wants to try that?
I'll do it.
Yep. What do you do?
So in brackets, 5x plus 3, power of -1/2.
Ooh, you don't need the
Oh.
minus. You don't need the
Or
minus.
just 1/2,
Why don't you need the minus?
because it'll be a fraction. No?
Well, you mean it would have already originally started off as a fraction. Is that what you're trying to say?
Yeah.
Like, you'll
Yeah.
need a negative if the bottom, or if that expression is in the denominator. If it's already in the numerator, then don't do anything with it. It's fine. You just have
Yeah.
to consider that. So y dash or dy dx.
1/2, 5x plus 3, power of -1/2, is it?
Times,
Times 5.
and then that's on the top. That's on the bottom.
Yeah.
This -half goes in the bottom as +half, so square root of 5x plus 3. Are you comfortable? Eventually, would you be able to get from this line to this line?
I wouldn't write the 2.
Ah, what would you have written?
Just
Just
5 of
right?
no, square root of 5x plus 3. That's it.
Fair enough.
No, I
Yeah.
would times 5.5 as well.
Yeah, 5 times a half is 5/2. That's how I think about it. Instead of 2.5, because we don't want to write decimals.
Yeah.
So I just think it's easy to think of numerators and denominators. So that's a numerator, that's denominator. That is at the moment in the numerator as -half. But if I take it to the denominator, it'll become +half. So 5/2 root 5x plus 3.
Yeah.
Question. Yeah, go ahead.
I still don't get why you wrote the 2.
What do you mean?
Like
5.
2 root of 5x plus 3.
Yeah, but like that 2 has to be there. What would you do with the 2 then? Otherwise.
It would have been with a 5 when you times it.
Yeah, but that is 5. What's 5 times a half? 5 over 2. There it is.
Oh, okay, yeah.
But I'm saying instead of thinking of it like that, it's easier to just go, that's in the numerator, so there's your numerator. That's in the denominator, so there's your denominator.
Yeah.
I mean, but if this was a 4, what's 4 times a half?
2.
So there's no point of writing 4 over 2. You would have just written 2 in the numerator.
Yeah.
But 5 over 2 you can't really do much with. So what you're going to do is just keep the 5 on the top and the 2 on the bottom, which is 5 over 2.
Yeah.
Okay, question 30. Aiden, do you want to try question 30? I'll give you the formula. U dash V minus V dash U over V squared. That's quotient rule.
Yeah.
So U dash, the first one, top, differentiate, derivative of the top,
2.
times V
2x minus 1
minus V dash
minus 2 bracket 2x plus 1 over bracket 2x minus 1 squared.
Beautiful. Have you done calculus at school yet?
Yeah.
Oh, you have? Okay. Good. That works really well for you. 2 times 2 is 4x. Minus 2 minus 4x minus 2 over 2x minus 1 squared. You're not getting any marks for expanding the denominator. Just be aware of that. So don't expand the bottom. Excuse me. Negative 2, negative 2, negative 4. And you're done. Anybody have any questions for us? Question 31. Y equals 3x squared Natalia, you want to try this one? Same thing. It's a quotient rule, so U dash V minus V dash U over V squared. Do you understand quotient rule now, or how to use it?
I'll try do it and then we'll see.
We'll see. Fair enough. Go. U dash. Sorry. U dash.
6x
Correct. Times V
just x minus 5.
minus V dash.
Just 1.
Yep. Times.
3x squared.
Yeah, I usually don't write 1. As you guys, like, you're in your 3rd week of, I guess, this. I don't really keep writing 1s if there's 1, so just 3x squared. Beautiful. Over.
X minus 5 squared.
Yeah, you pretty much get it. 6x squared, take away 3x squared is 3x squared. I just did it in one line. 6 times 5 is negative 30 over x minus 5 squared. No need to factorize the top. It's not like that. So that's full marks. Perfect. And lucky last, question 32. X squared, right? It was x squared plus 1. Yep. Who's going to give this one a go? Mira, you want to try it? Or you don't feel confident enough yet?
Fine, I'll try it. I don't know if I'll get it.
Good. U, V. All right, U dash. So what's the top one differentiated?
Is it U?
Yeah, so
I mean, is it X?
no, the derivative of x is 1.
Okay,
So
yeah.
that becomes 1 times V, which is x squared plus 1, minus V dash now. So what's the derivative of x squared?
Is it 2?
2 what?
2x.
There we go. And then that's V dash times U, which is x
X.
over V squared.
X squared plus 1 whole squared.
And then that becomes x squared plus 1 minus 2x squared on, and you're pretty much done. X take away 2x squared is negative x squared plus 1 on x squared plus 1 squared. All right. And then, I mean, last week we also learned tangents and normals. So you know what, I might as well just do a bit of revision on that. That's equally important. No, we did these, but still. Well, better yet, how about this? We'll just go find one from exams. Do I have any in here? No, I haven't organized this bit yet. Alright. And it's like this one. Oh, there you go, first principles. The multiple choice. What is the gradient of the tangent? Yeah, we should be able to do that, but I would like to just find a tangent question. Let's see if we can find a tangent question. Differentiate. Look at that. Easy, easy. Quotient rule. So that's part of logs. That's what we're going to be doing today. Limits, and that's it. So the only question they had there was gradient for a tangent. Oh, we'll do that one. What is the gradient of the tangent at this point? Right. So what is the gradient of the tangent to the curve y equals 5 plus 2x. We won't just find the gradient, we'll even find the tangent as well. At -2, -3. All right, what do we do? Find your gradient. You first differentiate, right? That's what we learned. And that's what you've been doing this whole last few weeks. So dy and dx equals 2, take away 2x. That gives you your gradient function, so that's everywhere. You want it specifically at -2. So your gradient of your tangent is 2, take away 2 times -2. That's +4 plus 2 is 6. So the answer obviously is 6 for your gradient. If you wanted to find your gradient of your normal, you would still have to do everything the same and then get to here and then go negative flip. And if the question did not say find the gradients of either the tangent or normals, but instead said find the equation of the tangent or the equation of the normal, then you use y minus y1 equals m x minus x1. And then you do whatever you like. Bring the 3 over, 6x, 12 take away 3. Boom. And this one, same thing. Y plus 3 equals gradient m x minus x1. this case, I multiply my 6 over, that's what I was trying to tell you guys last week, negative x, negative 2, bring everything to one side, and that would be the equation of normal, whereas it's the equation of tangent. And you can leave it in any form. So that's gradient instep form, and that is general form. There you go. That was last year's example. All right. Do we have any questions on that? No?
I didn't have a question about that, but I just remembered, like, when I was like going over through algebra, I went through like a couple of like past papers, and there was like this scientific notation question,
Yes.
and I didn't forget, but I didn't know how to do it. Could you quickly just do it?
The good news is scientific notation is actually out of the syllabus now.
So it won't be a part of like.
Well, it doesn't work like that, I guess. What we mean by out of the syllabus is in it's assumed knowledge. Now, it's not specifically going to be tested because it's not a specific skill taught in year 11 and 12. But because it's assumed knowledge, it's like you understand the ideas of scientific notation. But so it won't be technically tested, but it might be used in a question somewhere that you might need to understand scientific notation or whatever. So in saying that, let's just do it. It's not that hard. So if you got the number 6,000, the idea was to write this in scientific notation. It's always times 10 to the power of something. This number here must be greater than 1, but smaller than 10. Obviously, what number would that be? It's got to be greater than 1, but smaller than 10. It will be 6. 6 times 10 to the power of, and then you just count how many numbers until you get to the end, I guess, which is 3. If you had a number that was like this, again, this number here must be greater than 1 but smaller than 10, so what would that number be? It can't be 586. What would you choose?
5.86.
You are correct. Times 10 to the power of. Obviously, it's not positive because you're not going to the right. You're going to the left. Start from here. You put a decimal there, and 1, 2, 3, 4, and that is it. You want to do more?
No, like those things, they're basic. I get that, but there was this question. It was 8.2.
8.2.
Times 10 to the power of 6.
Yep.
All over bracket 3.5 times 10 to the power of 8, close bracket to the power of 2.
Yeah.
Right.
And anyone can help her out on what she should have done with a question like this? Come on. I'm sure one of you. If the question said, I'm sure the question said evaluate.
Yeah.
Someone. A question like this, if I came up to you and just said evaluate this, you guys would just be like, whoa, I didn't get it. Really? They're all numbers. What can you do with everything that's just got numbers? Use your calculator. That's all you're meant to do. You can't actually do anything else. So you just go plug it into your calculator. I'll go do
The
it now.
answer be. Oh.
Yeah, I'm not sure. Yeah. So Hefty, that's what you had to do.
No, but then like when I went to like look at the answers, like it said like decimal times 10 to the power of something, so it wasn't just like.
Yeah. The answer is 6.69 times 10 to the power of negative 11.
So that's all I really had to do.
Yeah, of course.
Wow, I really overthought it.
Just numbers. There's no letters. It doesn't tell you to do anything. Just evaluate. Oh, thank God. Just put it in my calculator. But that's good. Like, it's good that you're looking at exam questions because you see such a basic question. You were thinking maybe who knows? Let's say you were thinking of differentiating or solving, or you start rationalizing and overcomplicating stuff. But as you start to do more and more exams, you start to realize, oh, is that all? Oh, is that what you wanted me? Oh, to solve sine theories for half. Oh, is that all I had to do? Okay, I was really overthinking it, or whatever. You'll get used to that. But that's the whole point of doing exams. So you're on the right track. Don't worry, it's good. Me, just so you're aware of, in my exam in the HSC, it wasn't the squared one, it was a cubic one. But the question I got in the first question of my HSC was pretty much this. And I had a mind blank because by the time to the lead up of the HSC, I was just doing the hardest questions. And the first question, question 1I, said factorize this. And I was looking at it for a good 2 to 3 minutes going, huh? How do I factorize this again? So, you know, don't think you don't have a mind blank and stuff. It's okay. And then eventually I taught myself to skip that whole question. So I skipped all of question 1, not just I. I went to question 2, question 3, question 4, 5, 6. Would have got stuck, came back to question 1 and realized, oh, silly, that's just a difference of 2 squares. But because I was working on all the hard questions, I wasn't even thinking of this basic year 11 stuff. So it happens, it's okay. But yeah, it's that simple. Just all numbers, plug them into your calculator. All right. It's time for indices. Indices is going to be a little bit weird today. So you'll probably have a lot of questions for me next week, which isn't a problem. Actually, I won't stop the recording. We'll leave it as it is. So take it as it is today. I highly recommend reviewing the laws, the log laws that we will learn today for homework, so that next week you'll pretty much find a very easy lesson. If you don't review the log laws, you'll be super confused still next week. So we'll start it off and we'll see how we go with these. So logs and exponentials. Now, logs is obviously very new to you, but exponentials you've already looked into when you were sketching, right? Sketch, you know, y equals 2 to the power of x. That was an exponential. Log or logs are the opposite of exponentials. So a log would just be like, you know, log 2, let's say, or log 2x, or whatever it is. And so these guys are opposites of each other. So a log is just another function, just like a parabola or a circle or whatever, trig. Log is just another type of function. The important thing that you want to remember as we work through this is that logs and exponentials are opposites of each other. Just like square root is the opposite of squaring, or adding is the opposite of subtraction, and multiplying is the opposite of divide, and you know, I can go on and forever. Sine is opposite of inverse sine, or inverse sine is opposite of sine. And yeah, logs and exponentials are opposites. So exponential and log are opposites of each other as well. So first thing we've got to review is index laws. Most of this should be fairly straightforward for us. A to the power of x times a to the power of y. Well, if I've got bases that are the same, what am I allowed to do to the powers?
Add them.
There we go. And then obviously if I've got bases that are the same, what am I allowed to do with the powers when they're divided?
Subtract.
And then power to a power.
Multiply.
Times
Anything to the power of 0.
1.
And then if I've got a negative index, negative indices are positive indices in the denominator. We should be pretty good with that because we've done calculus now. And at the same time, fractional index are just surds. Power of 1. So if that 1 wasn't there, that was like 5, just so you guys know that becomes 5. And the x is down there. Okay, a slightly more neglected rule and it is. I think this should be a part of the rule. So if you've got two terms that are multiplied here to the power of x, you can actually write each term to the power of x. Now, I think most of us get that. The problem is we just don't know how to apply it. So if I've got a question that says it's 6 to the power of x, well, that actually is the same as me saying 2 to the power of x times 3 to the power of x. So the funny thing is, you always learned that when bases are the same, bases are the same. You never learned when bases are different. But if powers are the same, you're actually allowed to multiply the bases. So again, if powers are the same, but the bases are different, you're actually allowed to multiply your bases together. Again, we know that. I feel like we know that because if I came up to you and I said, hey, what's 2x all squared? You would say, oh yeah, that's 2 squared x squared, you know, which becomes 4x squared. But you don't know it very well like this. And this is the way we're going to need to know it, because everything we're going to be doing is exponentials. All right. I'll let you review the indices stuff. That's more like term 1 stuff. I'm not really going to get into that just today. I'd rather start off our log laws. So there is a basic rule, there is a definition that if I've got an exponential, ax equals y, then technically you can convert that to a log just using this particular formula. Your teachers will teach you this and make you do it, but I won't, and I don't believe this is a very good way of learning conversions from this to this. I think that you should actually do it the longer way, which we will learn in a second. But so I will not make you guys do it from this step to this step. So if you ever ask me like, okay, so how do I go from here to here? I'll just tell you, I don't know how to get from here to here. We don't. That's not the way we'll do it. We actually prove it every time. So we actually will understand how to go from here to here instead of just using a definition, because it won't work. It only works for easy questions. It won't work for anything that you're actually going to get in your exams. So it's useless. So I will not use that definition. Cool. Laws of log. So log laws. These should sound fairly familiar because they sound like your index laws. So watch this. If you add two logs, so log x plus log y, it's actually the same as logging the two terms together, x and y. So log of x plus log of y is actually the same as log of xy. Cool? And you know that it sounds like your index laws. When you multiply your bases, you add the indices. Or in this case, it's saying if you add your logs, you can multiply the two terms. Or if the two terms are multiplied, you can add the logs. Obviously, what's the answer for this one? Log x take away log y?
X over y.
Yeah, right. Common sense. X over y. This is probably the second most important rule. The most important one's coming up, but this is probably the second most important rule. Powers. If I've got a power for a log, that power can get dropped down. So it becomes a log x. That's really, really important because, I mean, if you think about all the exponentials, you've got x's on the top. If you were somehow able to log it, think what's going to happen to that x. It's just going to drop down. So that's going to be amazing. So we need those ones. If you've got a power, you can bring the power down. There it is. If you've got log of a with a little sub base, we'll talk about those again soon, but if you've got the same a and the same sub base, that just equals to 1. And if you've got log of 1, it's always 0. Okay, any questions? Okay, so a. Log 2 is equal to m and log 3. So first thing you're probably seeing is these sub-base a's. These a's right now, for the stage you're at, you can just ignore. That it won't do anything to you. So log 2 equals to m, or log 2 sub base a is equal to m. It's just going to be longer for you to say, a lot harder to say. You don't need to worry about it just yet. You won't need to worry about it for a lot of the questions. But for now, we can completely ignore it because they're all a's anyway, so that's not an issue. It's saying given log 2 is equal to m, log 3 is equal to n. Write the following in terms of m and n. The first one says log 4. Now, log 4 is somehow log 2 or log 3 just hidden. So all of these numbers are in fact just log 2 and log 3. Log 4, let's start with that one. Okay, can anyone tell me how else I can write 4?
2 squared.
Beautiful. And then what are you allowed to do with your powers?
Bring it down.
And then you get 2 log 2. And what does log 2 equal to?
2.
Log 2 here equals to?
M.
M. So therefore your answer is 2.
M.
That's it, you're done. Beautiful. See, it's going to be weird. The first lesson will be weird. It's just getting used to all the formulas.
Say wait, this like second line, like
Yeah.
2 log. No, the one on the
2 log
bottom.
2.
Yep, 2 log. Is that 2 log squared or 2 log 2?
No, that's actually 2 log 2.
Okay.
So 2 log squared would look like this. 2 log 2 squared, let's
Okay.
say. Or squared with it up here or whatever. So that's in the same line. Base, power, sub base. All at the bottom of your G. Log 27. Who wants to try that one? And it's just going to be 2's and 3's just hidden.
Wouldn't it just be 3 squared?
Ooh, not 3 squared. 3 squared is not
3 cubed.
correct. 3 cubed. And then what do you do with the 3?
Bring it down.
And then what does log 3 equal to?
N. So it'll be 3n.
Log 1.5. Come on. Someone's got to try it again now. Log 1.5.
Oh, can we do a fraction form?
Yeah, that's not good. You tell me. What do you want to write?
So 3 over 2.
So log 3 over 2. And what do you know when these two are divided?
It's subtracted.
Yeah, log 3 minus log 2. What's log 3? N, take away M. She's on fire. Log 12. What does log 12 become? There's a
I'm
lot of
guessing you can also do times if you can do divide, right?
Of course, so then that becomes log
3 times 2.
3 times 2 is not 12.
Oh, 3 times 4, I mean.
3 times 4, but 3 times 4 is 3 times 2 squared. I think that's what you were trying to say. 3 times
Yeah.
4 is 12, which is the same as 3 times 2 squared. And then what do you do when you multiply?
Add.
You add your logs. Yep. 2 squared, we've already worked out here. It's just 2m. So your answer is log 3, which is n plus 2m. E, log 18. I know Nick is answering everything, but like the rest of you, are you guys confused, or you get it and you're happy for it to answer it?
I'm confused.
Are you confused about every single one that we've done?
C and D.
C, log 1.5. 1.5 is 3 over 2. Do you understand that firstly?
Yeah, yeah.
And then what do you do when you divide?
Times.
Divide. When you divide,
Oh, you.
the log law is, yeah, when you divide, you subtract your logs.
Okay, yeah.
So when you're dividing here, you got to subtract your logs. And same thing with this one. 12. 12 is 3 times 4. But 4 is 2 squared. I just thought of writing it like that. So you guys understand you want to use more 2s and 3s than 4, let's say. So 3 times 2 squared is 12. What do you do when you multiply? Add.
You split them plus.
Yeah, plus. That's it. Adding your logs, and then log 3 plus log 2 squared. What's log 2 squared? Well, 2m, and then log 3 is m.
What if there's a different way of writing 3 times 2 squared, like a different numbers?
Doesn't matter. You tell me 18 now. Your turn. You tell me. You just do whatever you want. 18. Because you want to bring just 2s and 3s in eventually. That's the idea. So you tell me.
3 squared times 6.
3 squared times 6, or 3 squared is...
No.
Make it easy. You tell me. 6 times 3, is that what you're trying to say?
Yeah.
Okay.
But does it have to have a squared in it?
No,
Like
it doesn't. Eventually it would, but hold on. Log 6 times 3.
Then
You
you could have said 4 times 3 in D.
In
Could you
D,
do that? Yeah.
of course. 2 squared is 4.
Not did you have to write the square? Why did you
No.
have to write it?
I just wrote it because you guys have to know it's going to be 2s and 3s eventually. So watch this. 6. You're going to write log 6 plus log 3. All right. Log 3 is n. That's great. What's log 6?
No, there isn't.
There isn't. So what are you going to do with log 6 now?
Divided by 2.
You can't just divide it by 2. You can't just get rid of it the way you want to. The log 6, you got to break up log 6 even more, because 6 is not the best choice. So the log 6 is 3 times 2.
Yeah.
You get how I'm saying it's got to be these numbers? So
Yeah.
And then log 3, again, log 3 plus log 2 plus log 3. Log 3 plus log 3 is n plus n, which is 2n plus n. Now I'll show you what I would have done. If I had log 18, I know log 18 is log 9, because 3 squared times 2. 2.
Yeah.
So then I would have written log 9 plus log 2. 9 is 3 squared. Bring the 2 down. I get 2 log 3 plus log 2. Log 3 is n. My answer is 2n plus n. So it doesn't matter what factors you're picking. I think that's what you're asking. 9 and 2, 6 and 3. It doesn't matter. It's just, are you happy with 6? Well, not really, because you can't even bring in your m and n in. So you got to keep going.
Yeah.
So here you could have chosen 12. You could have done 6 and 2, 4 and 3. And that's about it. But you pretty much need to learn it to get to 2 squares, or 3 squared times 2. F, 13 and a half. 13 and a half is what? 27 over 2?
Yeah.
And then that just becomes log 27 take away log 2. Log 27 we've already worked out here. 3n take away n. Okay, let's try a HSC question. Log B is 2.75. Log C is 0.25. So log B is 2.75. Log C is 0.25. Find the value of log B on C. What do we do?
It's a divide, so would it be minus
What would you write? Log.
log B minus log C?
Yep. Which equals?
2.75 minus 0.25.
You just got yourself 1 mark in the HSC. Good stuff. And I do that on purpose. Like we do these exam HSC questions on purpose so that students realize you don't need 1,000 textbook questions. All you need is once you understand some of the basics, like Nikki seems to get it, I'm just saying divide, you just subtract, you just jump into HSC questions, you realize how simple the questions are, and that's it. Exams, exams, exams. All right. Log BC all squared. Ooh, what do you do in this case? Squared.
Would you bring the power down?
You must bring the power down. And then you're left with log of B and BC. What do you do with BC like this?
If it's together, so would it be times?
Ooh, it is times already. So what are you going to write it as?
Oh, so you would add.
Yes, that's the one. When they're multiplied, you add your logs. Log B plus log C. That becomes 3 times 2, which is 6. Nikki, did we do logs last year?
Yeah, I was doing it before. That's why I know this.
Nice, nice. What, you were doing it before, as in at school you're doing it now, or?
No. As in, we did log last year, and I have like the booklet that we did last year.
Oh, nice. Great.
Yeah.
That's good. That's the whole point of why I did that all last year. So it's a lot easier second time, and then third time you guys review at school, and then fourth time you review for your exams. It should be really, really good by
Well,
this
we're
stage.
still on trig. We haven't even started anything else.
I know. Like I said, logs, you probably start at logs next term. That's how slow your scores are going to be. And then calculus, hopefully by the end of the term, you'll start that, and then probability by about week 5 of next term or week 6. Or some schools usually don't even get time to finish off probability. They get into their year 12 year. But for us, we're going to finish off logs obviously in 2 weeks' time, and then we're pausing until probability next term, and we'll just revise for like 15 weeks. So we should be pretty good for our prelims.
Are we going to do past papers?
Yep, that's exactly what we're going to do. Right after when we do logs, all we're going to do for the rest of this term is just past papers. So that you can learn, your brain can learn to switch off, let's say logs, switch on trig, switch off trig, switch on calculus, switch off calculus, switch on functions, switch off functions, and so on and so on. That takes about 10 weeks for your brain to adjust to that, which is why we need it. Good, we're killing it. Anyone have any questions for us before I move on? Maybe we'll do another booklet or style of question before I move on to these ones. Logs. We will do. Try this. It says log B is 3.14, log C is 2.45. Find log B on C. So try that. Log B is 3.14, log C is 2.45. Find log B on C. Should sound familiar by now.
Can we still ignore the A at the bottom?
Yeah. You know why you can ignore it? Like right now, all you need to know is if they're all A's, then it's pretty much useless. That's not doing nothing. So yes, you can ignore it. When it will be different, then no, you cannot ignore it. But like they don't really ask that in exams. It's more your textbooks. Of course, log B on C. Mega, what did you think to do for I?
Minus it.
Yeah, it's that easy. Log B minus log C. So the answer is 3.14 minus 2.45.
0.69.
Thank you. Log of square root BC. Square root. We don't like the square root there. So my first thing I'm thinking of, same as calculus, try to link your maths. Don't separate your maths. We don't like our square roots. So I'll bring that all to the power of a half. But you know, in log laws, it says that if you've got a power, you're allowed to bring your powers down. Whereas in calculus, you brought it down and you subtracted 1. So bring it down. Bang, bang. Hey, that looks pretty familiar again, right? It was exactly like the one we just did. This one said squared times 2. This one says power of a half. So the next line is half. And then log BC becomes log B plus log C. And then obviously you just plug it in. I'm sure someone will give us an answer. Try triple I.
Sam, for the second question,
Yes.
do we have to when we write the answer,
Mm-hmm.
do we have to write half at the beginning?
No. So you'll plug like log B is 3.14 plus 2.45, whatever that is, times by half. So in your calculator, you're just going to
Okay, yeah.
bracket, 3.14 plus 2.45.
Okay, yeah.
So I'll get you the answer as well. 3.14 plus 2.45 times by half is 2.795.
Yeah, I got that.
And then triple I. Triple I, are you allowed to bring the power down of 3? You're not allowed to bring the power down just yet because there's a power of 2 down here as well. So what's your first line for triple I? Nikki, what do you think since you're on fire? Log B cubed on C squared. What's going to be your first line?
Subtract it.
What would you write?
Log B minus C, log C.
You're forgetting the only thing you keep doing, and you did that in calculus as well.
Oh, but you just squared, cubed
Power.
it squared, yeah.
Yeah, come on. Log B cubed minus log C squared. And then what do you do with your powers now?
You bring them down. So 3 log B minus 2 log C.
And then, of course, log B is 3.14, log C is 2.45, and we are good. Put it into your calculator, you go.
So we're doing these questions, right? And Nikki's all like, ooh. Nikki,
Yeah.
you know how you did like the second line, right?
Which way? This first line or the second line in here?
Yeah, like 3 log B.
Yeah.
Oh, we put the powers down. Is that how you got 3 log B?
Yeah.
Yeah.
Okay.
Yep, powers coming down. Power coming down.
Sam, can you do that with numbers? Like another question with numbers.
What do you mean?
So like log, wait, you know how it's log, like B
Yes.
cubed over C squared?
Right.
Could you replace the B and C with numbers?
And do this question? No, you can't because you need them to be actual B's and C's.
Mm-hmm.
The answer for that is 4.52.
Thank you. We are going to deal with numbers soon, but all we're going to write with numbers is just log like 3, 2, and that's it. There's not really, there's not really math involved. You're just going to plug it into your calculator. So, yeah. You want to do some more of these? Let me have a look. I've got any here. Yeah. Okay, actually, here's a numerical version of one. So it says write each of the following as log 3s. Right, so we're trying to write each one of here as log 3s. So 81. 81. Well, how are you going to break up 81? Think of it the same as I tried to explain it up here. I said you've got all these numbers, and all these numbers are 2s and 3s just hidden.
Do we do 27 times 3?
Yes, but still 27 is not good. You're on the right track.
3 squared. I
Three
mean,
s-
3 cubed.
9.
Yeah, 9.
Is it 9 times 3?
You're getting there, and then, but 9 is not good. So, in fact, you're you're pretty much there. You're just not seeing it. 3 to the power of 4 is 81.
Oh, okay.
Because, what you just said, 27 times 3 is 81. But 27 is 9 times 3 times 3 equals 81. But 9 is 3 times 3 times 3 times 3 is 81.
Okay.
Yeah. But you need to know more than, how you guys are going, 27 times 3. You need to tell yourself, but 27 is not good. So you shouldn't be really thinking of 27s. What you're trying to do when you're working out your numbers is you start off with this base. You think about, okay, how does 3 relate to 81? And then 3, squared, cubed, and then I would try powers first. That's my clue. 3 to the power of 4, okay, and then what would you do now? Because you only want log 3s. You don't want log 3 power of 4. So what are you going to do with the power? Bring that power down, and that just becomes 4 log 3. So log 81 can be written as 4 log 3.
Wait, I have a question.
Yes.
So you don't have to actually make it log 2, 3, right?
Log. Firstly, the way we say it is log 3 and then say 2.
Okay, log 3, 2.
Yeah, but tell me, what are you saying? So
You don't have to actually turn log 81, 2 into log 3, 2.
Well, we did. We actually did change it to log 3, 2. Just multiplied by 4.
Okay, yeah, so you can have the 4 in the front.
Yes. Yeah.
Okay.
When it says write each of the following as this, that means this is something and then this. It's nothing else. You can't see anything else other than at least log 3. You can't have a log 6 or a log 27 or whatever. All right, what are you going to do with this one? Log 2 root 3.
Would it be 2 over 3?
Did you say 2 over 3?
Yeah.
2 over 3. No. It's multiplied. What are you doing? It's multiplied.
Divide. Alright.
Add, not divide. Divide, you would subtract. Multiply, you add. Just think of your index laws. What did you do when we gave you something like this? Multiplied, you added the index. So add, and then what happens when you divide? You subtract the indices. So same thing. What do you do when you multiply these bits? There you're going to add your logs. So it's going to be log 2, 2 plus log root 3. Does anyone remember what log 2, 2 becomes? If you've got the same base and the same subbase, that actually becomes 1. We're about to prove it soon. But that just always becomes 1. That was that law that said log AA. Square root of 3, what do we do?
Would you do 3 to the power of 1 over 2? Yeah.
And then what do you do with the half?
And bring it down. So
Bring it
half log, 3, 2.
Yep. 1 plus half log 3 sub base 2. Perfect. C. Any questions about that one? Let's try C. Log 8 over 9. All right, last one. What do you do now when it's 8 over 9? They're divided. So what do you do when they're divided?
So 8 minus 9.
Log 8 minus log 9. Be strict with yourself. Actually say log 8 minus log 9. All right, log 8 is obviously log 2 cubed. Log 9 is 3 squared. Bring the 3 down. Bring the 2 down. That's your log 3. That's done. What does log 2 equal to again, Larson?
1. 1.
So your answer is 3 times 1, which is 3, minus 2 log 3s. And you're done.
Yeah. Yeah.
Good work. Anyone have any questions? No? Okay. So change of base. So this is the one that I said it's probably the most important formula. It's this one here. So there's got to be a time when we have to actually evaluate that on our calculator. And they're not actually that hard. All it is to be able to write this particular expression into your calculator, you just go and put log 3 divided by log 2. So the good news is your subbases can actually be written into your calculator as just fractions. So you'll put log 3 over log 2. If you do that, you guys can see where your logs is. It's just on top of your cos. Log 3 over log 2. You should get 1.58. Okay. Anybody not get that? All right, brilliant.
Could
So,
you explain that again?
yeah. So if I've got log, again, if I've got log of 7 and 10 here, so that's log 10, subbase of 7, I should be able to actually, because right now, try to put that in your calculator, just like that. You won't be able to. But what you can do is you can change your base into a fraction. So this can actually be written as a fraction. How? It is log of the top number over log of the bottom number. And then, again, press your fraction button now on your calculator. Press log, and then 10, close your bracket, go to the bottom, log 7, close your bracket. You shall get 1.18. Did you get that?
Yep.
So it's just a way to convert these into fractions. The reason why we need to learn to convert these, because if I actually came up to you and said, please evaluate this, you can't do much with that. You can't do much with that. You've got to be able to actually plug it into your calculator, and the way we can do that is by using fractions. So log 3 subbase 2 is actually a fraction of 2 logs. So log 3 over log of the bottom number 2. Now to confuse you even more, the log that we're going to use is not so much the log log. Right next to your log button, you'll see another button that says ln. So you've got log and you've got ln. Now log is what we say is a base 10. Now I'm going to confuse you a little bit here, just so you can hear the word, but you don't need most of what I'm about to say. It's just that you got to accept what I'm about to say. Log is base 10. Base 10 means we count in tens, so like 1, 2, 3, out the way we've learnt numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you start again. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You start again. 21, 22, 23, 30. You start again. 31, 32. Start again. 40, 41, 50, 60. So we go up increments of tens. That's what a log does. Right? It's got a base of 10. Your ln actually has a little sub-base here of e. So ln is the same as log e. So this one has a base e. Now e, just like pi, is a number. E is about 2.71 and it goes on forever. If you wanted to work out what e is exactly, press Shift ln. You can see on top of the ln it says e, and then just press 1 as the power. You should get it 2.71, 828, 1828, and blah blah blah. It just goes on. Right? So E is just a number. Don't be afraid of E. Don't think it's a letter. It's actually a number, just like pi is. Pi is also a number. Right? 3.14 goes on forever. That's what E is. Okay. Now, ln has a base E. And what you want to know is logs and exponentials are, I mean, they're brothers and sisters. They're the opposites of each other. Right? They work really, really well together though. Whereas log and a base 10, so a number system and logs are two different functions. This is the numerical system, this is the log system. So they don't work really well together. You will not see me use log in my calculator. Unless the question was it just said do log 3, just log 3. If it just said that, fine, I might just put log 3 in my calculator. But even if it said this question here, I will not use log. What I want you to use is ln as much as you can. So this one here, put ln3 on ln2 in your calculator. It should give you the same answer, it'll still give you 1.58. Right, so we saw that, ln3 on ln2, still gives you the same answer, so we can use this. It's just a different base. Now, the one that's more correct is this one. And you won't need to understand it too much just yet, like I said, but this one's more correct than this one. It's just because of the different base that it's got. So whenever we're going to talk about logs, we're mainly talking about ln's. Logs, not these logs. That's confusing because this actually says log, right? But that's the log we're talking about. All right. Once you've wrapped that around your head and you've understood how to do a change of base, we can actually see this applied. So, let's say if I've got a question here that says 2 to the power of x equals 7. So we're trying to solve 2 to the power of x equals 7. Now my question to you is, what is the opposite of an exponential? What is the log? So what would you do to both sides?
You would
log
it.
Yeah, you're right. So just like you know, if you had this question, you would say, okay, I really don't like the squared there, so what's the opposite of squaring? You would say, hey, you got to square root both sides. Right? So you log both sides. That's the opposite of the exponential. So it looks like this. Now, what are you allowed to do with this power of x?
Bring it down.
Ooh, look, something that was really hard. Look what we're about to do. We're bringing it down. And then this is just a number, log 2, so I'm just going to divide it. And something that was really hard to solve now is really easy to solve because you've learnt logs. Plug that into your calculator and you're done. 2.807.
Wait, but would you actually plug in ln or log?
Yes. No, that's what I mean. I want you guys to get used to ln.
Okay.
ln is log, it's just a different base, but I want you to more plug in ln. Even if I ever write log 7 over log 2, I want you to write ln 7 over ln 2. Because that's what we mean. Like we use them interchangeably, but we mainly mean ln. The only time you ever going to actually use log 3 compared to ln 3, because there is a difference between the two answers, if you plug that in, is if I specifically only ask for log 3. Only. If I ask for anything else, it's ln. If it just says log 3 as a number, or log 4 as a number, or log 5, log of just a number, then you use log. Every other time, it's meant to be ln. Okay. Any questions? Cool.
Can you do another question?
Yeah, it's coming. There it is. For again, once you understand one question, you just jump into exams. It's the best thing. There's no point of doing textbook questions because they're very repetitive. You're not learning anything from it. So this is from the 2010 North Sydney Boys Extension 1 Prelim Yearly. Rewrite 2 to the x equals 5 to the y with x on y as the subject by taking logs to a suitable base. All right, here we go. What do we do to both sides? We don't like these powers there.
Bring them down.
Nope, that's not
Log
allowed.
it.
Log it. Keeping steps, Larson, not allowed. Log. Now what are you allowed to do with your powers when you've logged it?
Now bring it down.
You can bring your power down only because of the log. Yep. Now you're up to this stage. Look what you're trying to find. What would you do?
So x over y, and then you would do log 5 over log 2.
Absolutely. You bring the y over to the left-hand side. You bring your log 2 to the right-hand side. Eight to the power of x over y. What does x over y equal to? Log 5 over log 2. Plug that into your calculator and you're done.
Wait, but doesn't it say exact value?
Yeah, plug it into your calculator.
Okay.
Wait, are you thinking exact value as in trig?
I'm just thinking, never mind, I'm just thinking different things.
Well, no, if you were thinking of exact value because of trig, the idea of it, well, definitely you won't use trig, just so we will get that clear. But exact value just means we can't have a irrational number. Irrational means you can't have like root 2 and you're writing it as 1.414, blah, 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 blah. We want it actually perfect. We want it with the surd there. We don't want it rounded. So
Yep.
when you plug this in, it should give you 125 exactly. It doesn't say 125.364218. If it did, then we have to do something else to it, which it won't in this like at all. So exact value is just a whole number pretty much. Okay, anyone have any questions for us? Okay, that's it. Well, what I would like to do maybe answer these questions. Do I think we are ready for this? Just not yet. It's all right. Wait, let's do these ones first. Oops. Okay. Solve log equations. So we've got to learn log equations. We've got to learn exponential equations. First one's log equations. Solve this. Okay. 2 log 3x equals, looks like a big bunch of, a big mess, doesn't it, right? But it's not that bad. There are rules. You follow your log laws, you shall be fine. I want to first understand that I've got to get rid of the logs, right? Because I don't really want the logs there. So what I've got to do to solve for x, what I've got to do is bring this 2 back up as a power here. So this would look like this. Now the reason why I've done that is because for me to be able to cross out my logs, your logs have to be monic. So there must be no numbers or anything else in front of them. They can only be singular logs. Now I don't like this 3 either, right? That's a bit annoying. So what I'm going to do, I know my change of base, so I can rewrite this as ln x squared on ln 3, which equals to right? Change of base says log of x squared over log of 3 equals log of the top one over log of the bottom. Now what you'll learn eventually is if you got 3 and 3 here, you can actually cross them out, because when you put it as a fraction, essentially you can cross them out anyways once you're going to bring them to one side. So that your fractions will always, your bases or your sub bases will always cancel out. That's why I've just from the beginning I was saying you can ignore them. Okay, we're up to this stage. I'm going to pause. Ask me any questions you have. So I'll put the 2 up, change of base, and then we can cross them out, but eventually you'll probably just start that from your first line and learn that these already cancel out. So you can pretty much ignore it, and you probably would have just written log of x squared is equal to log of 6 take away x as your first line, instead of writing this first line here. All right, any questions? No? All right. At this stage, you want to eliminate your logs. So what's the opposite of logging?
Exponential.
So you get rid of it, bang, 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 bang. Right, that's the whole point. You're doing the opposite to get rid of it. What are you left with then, Nikki?
X squared equals 6 minus x.
And that looks familiar, doesn't it? Back to term 1.
Yeah.
Everything's just going to go back to algebra. That's what I was telling you guys last year, what I've told you this year. Strong with the algebra, every topic's easy. Bang, bang. X equals -3 and x equals 2. Then you've got to always check. So sub in -3 into here. You realize you can't do log of -3. That won't work. In fact, you can't log any number less than or equal to 0. Just won't work. They have to be greater than 0. So -3 doesn't work. 2, log of 2 works. 6 take away 2 is 4. So the only answer is x equals 2.
I have a question.
Yes.
In a test, if you get like a question like this, when you crossed out the log with the exponential, do you actually have to write the e and then cross it out, or?
See, like eventually I don't. You'll just see me going, okay, there's 2 logs, cross them out.
Okay.
If that's what you're saying.
Yeah.
And that's how obviously all of the extension kids are doing it. They're not writing e's. But just for the time being, just so you can understand, if you've got a log, the opposite of a log is to exponential. So the way I'm doing it is very like elementary. It's like how you would have been taught this. Oh yeah, you got to square both sides. But come on, seriously, like from now, I think where you're up to now, you should already be able to just write that, because you guys can see it. Or you would just cross this out and write the squared there at least. You wouldn't really put squares on both sides and cross out and whatever. So yes, it's up to you. The rest of what I'm doing, like whenever you look at my algebra, it's up to you really.
Okay.
You know, I just go through the main concepts. Your algebra, up to you. Like here, some students might have not even factorized. They might have said, I would have preferred to complete the square, or I would have preferred to do quadratic formula. Whatever, it's up to you. But obviously the fastest version would be what I'm showing you with that in this case here. Yeah. Cool. Any other questions? 16. Again, you can't, it has to, remember I said to be able to exponential, be able to get to this stage, you can only have a log equal to a log. It cannot be log and then minus a log equal to a log. That's not allowed. So that should be clue enough for you to know what to do with this side. What do we do?
If it's subtract, would you divide
Yes.
it?
Yes, yes, you're on fire. Log 8, take away x. And then what do you do now?
You cancel out the logs because of
Bang, bang. What are you left with?
16x over 16x equals 8
16
minus x.
On x equals 8 minus. Yep, and then what do you do next? It's back to term 1, back to year 10, whatever. Don't even
Take
stress.
the x to the other side.
Yes. Then bring everything to one side. Then factorize. I can see it's a perfect square. You would factorize whatever. And then x equals to 4. Check. 16. Log 4 is not a problem. 8 take away 4 is positive. That's not a problem. So the answer is just x equals 4. What I'm doing when I'm checking is if I sub in 4, and if I get a negative number, so I get log of a negative, then there's a problem. But log of 4 is positive. 8 take away 4 is still 4. So log of 4 is positive. That's perfectly fine. So I know that's the answer. (2019) Normanhurst Boys High School, Extension 1, Task 2. This was last year's question. And you can see some of them, obviously, we've taken out from Extension 1, because the truth is, if you guys are only doing advanced questions, once this is asked in advanced, you're going to absolutely struggle because you haven't been used to it. Whereas the extension kids are going to be like, oh yeah, whatever, we've been doing this. It's easy. Now, there is no extension logs, so just so you know, there is no extension logs. So it's not like they get different questions or harder questions or anything like that. It's more that as extension students, they should be doing harder advanced stuff. And that's what I think with you guys. Okay, the A's are all the same. So what are you going to do?
They don't count.
Yeah, they don't count. Look, if you're worried about that, don't forget change of base. Change of base just means over log A, over log A, over log A, over log A. What are you going to do with all the log A's? Just cancel them out because they're all the same anyways. So it's good just to know they don't really count. So what you're left with is log 2 plus 2 log x minus log 6 equals log 3. Okay. Next line, what are we going to do? Log 3 is not a problem. This side's a big mess. What are we going to do? I can't actually multiply these just yet when they're plus. I can't multiply them because there's a 2 in front. Has to be monic for me to be able to use those log laws.
If they're all logs, can you cancel them out and because it's exponential?
Has to be one log equal to another log.
Okay.
If it's log, 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 log like this, actually you're not allowed. So yeah, you have to make it log equal to log like this. Yes, absolutely cancel out. Okay, so what are you going to do? Nikki, you want to try it again? Plus,
Oh, so you would do
Plus.
times.
yeah, so 2 x squared. And then what do you do when it's subtracted?
Divide. Oh, okay. That makes more sense.
Yeah. And then cancel, cancel. 2 on 6 is a third. And check. X equals -3. When you sub it in, you get log of negative. Log of -3 won't work. Therefore, your only answer is x equals 3. Any questions for that one? We'll do exponential equations next week. So let's do a few more of these. Let's at least do those two. All right. Who wants to try I? Doesn't matter if it's wrong. It's better to try it so you can learn where you're going wrong.
I'll try it.
Okay, go ahead. So 2 ln x equals ln 4x plus 5. Now, we would have liked to cross out the logs, but we can't because it has to be just a log of something equal to log of something. So I don't like
Yeah.
this 2 here. What are you going to do?
Make it the power.
So it becomes log of x squared equals log of 4x plus 5.
Yeah.
And then what do you do now?
Cancel.
Yep.
Or,
Bring it all to one side.
then. Yeah.
And then factorize. Do you know where your factors are? -5 and
1.
+1. Yep.
Plus
So
1.
x equals 5 or -1. And then what must you do right after that?
Check.
Check. If you sub in 5, 2 log 5 and is positive. 4 times 5 is 20, 25. That's positive, no problem. -1. Log of -1. Log of -1 is going to be a problem. So therefore your only answer is
5.
x equals 5. Double I. Who wants to try that one? No. Minus log of x minus 1 equals log 3.
I can try.
All right, go ahead.
So you would first. Wait, what's the question? Oh, okay, yep. So you would do. Oh, subtract, so you would divide. And then you would cancel the logs. So it's x plus 3 over x minus 1 equals 3. And then you would just take it to the other side. Expand. Take the plus 3 over.
I would have actually taken the minus 3 over to keep a positive x. It's better to keep positive x's than negative x's. So 3x minus x, and then 3 plus 3. I mean, it doesn't matter. It's just, it's better, I think, for you to remember. Try to keep x's positive. Makes your math easier. Less room for mistakes as well. You're not going to deal with negatives. So yeah, that's what I do. So I would plus the 3 over here, and then subtract the x over here. And
That's
what must
what
you do?
I would have done like after, but yeah.
Yeah, no, it's good to get to it from that stage there. And what must you do after that?
Check.
Check, because even if you get x equals 3, it doesn't mean it works. Like 3 plus 3 is 6, that's fine. 3 take away 1 is 2, so x equals 3 is fine, so therefore the answer would obviously still be x equals 3. Don't
What
forget
if it wasn't fine?
well, you know what's the answer. What's the answer? Go. If not, you tell me. What do you think
would
the
it
answer is?
be a math error?
Oh, we don't write math error. What do we usually write?
Oh, no solution.
Yeah, that's the one. It doesn't work. There's no solution. And that is a solution. I keep saying that. So don't worry. Like, that's perfectly fine. You get none of them work, none of them work. Good job. Nikki, I think you pretty much have mastered it. So,
I feel
That's
like I
cool.
still need to practice a bit though.
oh yeah, all the time. All the time. We'll do one last one. Page, pen page, select. All right. Here we go. So I get this question straight away. I go, okay, well, 7, you know, it's everywhere, so I don't need to worry about it. I've got 2 log 4 equals half log x plus log 2. Again, I go, I don't like these numbers in front, so log 4 squared equals log x power half plus log 2. I don't like the plus here now. I'm going to multiply these two things together. Now, I don't mind the logs because I can just cross them out. Now I'm left with 16 equals 2 x, or x power half, or root x, however you wanted to write that. 16 divided by 2 is 8. And of course you square everything now to get rid of the surd. Sub back in, positive, you're done. So you can see it starts to get pretty repetitive. It's just about knowing the rules really, really well.
I have
Oh,
a
yeah.
question.
Yeah.
What would happen if the 7 or like the A wouldn't cross out?
So we're going to do that next week. But if it wasn't, I'll give you a basic question. So if it was log 7, log 7x plus equals 4. Let's say it was that question. Obviously from that, it doesn't cross out, yeah? Because there's no log 7 on this side. So what you're going to do is you're going to bring the 2 up. Obviously, that just stays the same. You don't change that. You know that you can convert that using your log laws or your change of base. So it doesn't cross out. What do you do with a log 7 that's divided?
You would
You're gonna
bring
multiply.
it to the other side.
Correct, right? So that's all that would happen. It's just a bit more math.
Oh, okay.
Bring the 4 up. Get rid of the log. How to get rid of the 2? Whatever that would give you. I think 49. 7 to the power of 4 square root that answer is 49. Yep, so plus minus 49.
Would you need to check that as well? Or
Of course. And then check x equals negative 49. Log of negative 49 won't work. I think we're getting the idea of that. That just won't work. So therefore, x equals 49 is the only answer. But there, when the bases don't cross out, unfortunately, you just have to deal with fractions now. So it comes to algebraic fractions.
okay.
It crossed out like this. Crossed out, or even easier, because there's no more fractions. That's all. It's the only difference. You're either going to deal with fractions or you're not going to deal with fractions. The math and everything is still the same. All right. I'll send you all your work, all the booklets that we worked on today.